Hey everyone, let's start with question number 3 Digital Electronics asked in GATE Examination 2025. A 4-bit weighted register digital to analog converter with inputs B3, B2, B1 and B0 MSB to LSB is designed using an ideal op-amp as shown below. The switches are closed when the corresponding input bits are logic 1 and open otherwise. When the inputs B3, B2, B1, B0 changes from 1110 to 1101, the magnitude of the change in the output voltage V0 in millivolt rounded off to the nearest integer is. So now you have to keep in mind the key points of this question. Before starting this question, you have to first look the order, that is B3, B2, B1, B0, which is MSB is B3 and LSB is B0. Sometimes it is written upright, so you have to see carefully what will be the order. And the second important thing, it's look like R2R ladder, but it's not, because R2R ladder have resistance here, here, here and here, so it nots the R2R ladder. So most of the time student gets confused between R2R ladder and these general type of op-amp circuit. So what you have to do is not directly applying any formula. I hopefully discussed the R2R ladder asked in one of the previous year question. There I will tell you the various forms of R2R ladders so that you can apply the formula directly. Also which formula is valid for which circuit. So now coming back to the question, the second most important point is your answer should be in millivolt. So again, please read the question carefully. 99% of student makes this mistake while answering because it is a NAT numerical answer type question. So now we will draw the circuit of op-amp and start solving the circuit using KVL. What you gonna do? First write the first input, which is given 1110 and the second is 1101. So assigning these inputs to B3, B2, B1, B0, this is the MSB and this is the LSB. So B3 is set to be close, 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 and this should be an open. So writing the KVL equation, V reference minus 0 divided by R plus V reference minus 0 divided by 2R plus V reference minus 0 divided by 4R, which is equals to 0 minus V0 divided by R. Here this is an op-amp, we use the virtual short concept, so this point comes out to be 0 volt. Now R gets cancelled out and V reference value is 2 by 2 and 2 by 4, which is equals to V0. V0 is equals to 3.5 volt minus. Minus just comes just because of those who know it is an inverting op-amp. And same we are going to do for 1101, which is V reference minus 0 divided by R plus V reference minus 0 divided by 2R plus V reference minus 0 divided by 8R, which is 0 minus V0 divided by R. Again R gets cancelled out. V reference is 2 volt, 2, 2 by 2 and 2, 8 minus V naught. V naught comes out to be minus 3.25 volt. So you are seeing that it is little bit a long process, but this would be a method 1. I will go with method 2, which is much shorter than this, but before going, it is a general way to do this, so one have to know this method as well. So now taking the difference between V01 and V02, let's say this is V01 and this is V02. So what is the most third important thing which is asked is, the answer is the magnitude of the change in the output voltage. So irrespective which one is greater, you have to take the magnitude. So minus 3.25 minus of minus, which is 3.5, which is comes out to be 0.25 volt. Answer is in millivolt, so you can write 250 millivolt. So answer to this question is 250 millivolt. Now we can write the second method, which is much shorter, but you have to understand that the bits are of 4 bit 000 0001 going up to 1101 1110 and 1111. Total there are 16 combinations. So this is bit 0, bit 1 up to going 15 to 16. So now if you carefully see that bit 11110 is this one and 1101 is this. So if you look, that question asked is to find the corresponding analog difference, analog value difference between these two bits. So analog value corresponding to bit is, let's say, V01, and analog value corresponding to this is V02. So we already find that V01 minus of V02, which one is, which will be a greater. So this is nothing but finding the difference between the two. So what is the most important thing is step size between the two bits. It would always remain same. So what you can find, the analog value corresponding to bit 1, this is same as the step size, step size. So once you find the analog value corresponding to bit 1, you will get your answer without writing the difference of these two, because you already analyzed these are two consecutive bits. So the difference between the two consecutive bits is nothing but its step size. So writing down that 0001, we can write the KVL as V reference minus 0 divided by 8R is equals to 0 minus V0 divided by R. So now solving, R gets cancelled out, V reference is 2, so V0 comes out to be minus 0.25 volt. It is should be in magnitude to 0.25 volt, or we can say 250 millivolt. So answer to this question again comes out to be, obviously it should be a 250 millivolt. The second method is much good way of solving this, but the first method is more generalized form, so it will take more than 30 seconds more, but you will get your answer correct. Thank you.